My name is Edson Yanaga. I'm a Director of Developer Experience at Red Hat. My Twitter handle is @Yanaga. But since here in Romania you speak a Latin language, yeah? I think it's not that hard for you to pronounce Yanaga, because I noticed that Americans can't do that, okay? For me, I'm a Brazilian Japanese. For Japanese people, it's easy. Okay, but I don't speak Japanese. Okay. I know the name of the foods. I wouldn't starve in Japan, okay? But just that. And I've studied 4 years of Japanese. I can read, I can write, but I can't talk. I know, it's a shame. Okay. I'm also happen to be a Java champion and a Microsoft MVP, which is kind of weird. It was supposed to be very weird some years ago, but now that everybody is embracing open source, I've been talking about open source for the past like 10 years, and now it's very good to see that even the largest proprietary software company in the world has adopted open source. I've been awarded the MVP because of the, in fact, I'm the first open source MVP of Latin America. And they awarded me the title because I've worked with the guys on Redmond to add the Java support on Azure. So I think they are still behind other cloud computing providers. But I also believe that cloud computing as open source is a matter of choice. So the more options that we have to deploy Java applications, the better. So that's why I helped them to implement many of the features that they have today on the Azure platform for Java applications, right? And since I've been researching this subject, I've just released a book from Riley, which has the same title as this session, Migrating to Microservice Databases. So if you just access the developers.redhat.com, you'll be able to download the ebook for free now. Red Hat developers has bought the royalties for the book, so they are distributing the book for free at the website, at least for now. And if you take a picture and tweet and tag me on Twitter, I have some copies available here too. So I'll be able to share with you, okay? And if anybody wants, I may be able to sign that later too. Okay. And for the content, I always like to start my sessions with this sentence, which is not from me, but from Forbes. Now, every company is a software company. I like to say that you don't work for a bank. You work for a software company. You don't work for an industry. You work for a software company, because we all live in this kind of digital revolution, which is the digital economy. If you guys are standing in the back, we have some free seats here in the front. So you don't have to well, stand up. Okay. And the people here don't bite, so you don't have to be afraid of that. So some good examples of this new digital economy is that the largest car transportation company in the world owns no cars, which is Uber. The largest lodging company in the world has no real estate, which is Airbnb. The largest online retailer in the world has no stock, which is Alibaba. And the largest content network in the world produces no content, which is Facebook. All of these companies have something in common, is that they all exist because of software. So software is changing the world, and I truly believe that we, software developers, we are the most important people in the world from now on, because all of the great revolutions that is going to happen to the humankind is going to happen because there is a software developer behind it. So if you can change the world, it's better that we change the world for the better. I also like to introduce myself as a software craftsman, and many people have different definitions about that. The best definition I have for this is that a software craftsman is somebody that cares about his job, or his or her job. So we know that we can change people's lives for the better, and we know that we can make them miserable too, because we know how is that miserable feeling when we use crap software that is not attend our expectations. So I decided some years ago, not that much, unfortunately, that I would, instead of making people miserable, I would choose to make their lives better. That's why I decided some years ago that instead of just bashing or complaining, I would take a step ahead and try to help people to make better software worldwide, and that's why I'm so happy to be here today. So maybe with some of the things that I can share with you today, we can all deliver better software to help people to have better lives, including ourselves. And the great discussions, I'm pretty sure that you're seeing a lot of talks about DevOps and microservices and everything else. I won't be discussing that because we don't have time today. But I'd like to make you have a special attention to just one point about DevOps and microservices, which is the feedback loop. The feedback loop, we use that on daily activities. And the shorter, the better the feedback loop that we have when developing software, the better software we deliver into production too. And technically speaking, the most important thing about DevOps and microservices and the feedback loop about this concept is, again, this is a technical term, it's the batch size. The batch size, we define that in the DevOps world as the amount of things that you deliver into each release when you put that into production. So the more things that you pack together when you deploy that into production, the worse the software that you deploy. So our main objective when trying to do some DevOps and microservices is try to reduce the batch size, because the smaller the batch size, the faster the cycle time. It means that we can deploy it more frequently, and if we can deploy more frequently, we have a better feedback. We know that if anything broke into production, we know exactly, we have a very few things to check to see what happened. So the smaller the batch size, the better your life. And I'm not saying to you that you need to have like a one commit batch size, which would be the ideal thing. But maybe for many industries like banks, we have some successful customers using that. For banks, you can have a batch size of 1 week. And really, for a bank, you can't do smaller than that because people have to check a lot of compliances and everything else. So maybe for your industry, a batch size of 1 week is more than enough. What I think is not acceptable is for you to have a batch size of 1 year or 6 months. So if you're deploying like every 9 months, maybe you can do that every 8 months. So the goal here is not about, oh, I want to do one commit, one deployment. No. I want you to all think that we need to reduce our batch size, and for that we need continuous improvement, because if you do that 9 months, maybe you can do 8, if you do 8, 7, and so on. But if we try to reduce our batch size to the smallest possible amount, we have one problem, which is caused by the ops guys, which is called the maintenance window. I want to deploy that every day or every hour, but you won't be able to do that because you have a very specific maintenance window to deploy your software. That's when the ops guy allow you to deploy. Why? Because usually deployments implicate in downtime, which means that you're going to disrupt the user into production. And you're not allowed to do. You mean it's like in the middle of the day, people are buying, selling, and processing some stuff. You're not allowed to stop the system. Oh, I'm going to stop the system for half an hour just to upgrade that color of the button. Okay? You're not allowed to do that. So if you want to reduce further our batch size, we need something that we call zero downtime. We need zero downtime deployments to be used into production. So it's a concept that is very well explored in the DevOps world. So, but the basic requirement for a zero downtime deployment is that we need a blue-green deployment. And a blue-green deployment, I'll explain that very quickly. And please, I know that I tend to speak very fast, and if I speak too fast, please somebody warn me. I'll try to calm down. And for a blue-green deployment, it means that in the past, we used to have just a single deployment, which means that our clients were issuing requests to just a single set of servers. And now for us to have a zero downtime capability, we need to add another component to our architecture, which is a proxy. Now we have a component which sits between our clients issuing the request and the servers that are receiving this request. The proxy, when we have a proxy, which basically just forwards the request to our backends, we now can create another set of servers, which each of them have equal capacity to handle the production request that we have. Then we can have, like we say a blue and a green deployment. And in the DevOps world, we always say that the blue deployment is going to be the current or old version, and the green is going to be the new one. Okay, you see why. When we have two sets of server, we can achieve zero downtime deployment when we, like, I want to release a new version. I can take the green deployment from production. I can shut down the servers. I can copy the artifacts. I can start up the servers again. I can wait for them to warm up, because we know as Java developers, I think most of us are Java developers, right? Okay. Then sometimes Java takes a bit of time to be warmed up, to be fast. So sometimes we need to wait the server for a warm up. And when it's okay, then we can go to the proxy and put the green deployment back into production. It's going to handle all of my requests. If the green deployment is working correctly, then we can do the same with the blue. Then we can shut it down. We can copy the artifacts. We can start it up. Maybe we need to reboot. Sometimes people do that. And then we can wait for them to warm up. And when everything's okay, we can put the blue deployment back into production. Then if both are running the same version, then maybe we are allowed to just load balance the request between one and another. But the blue-green deployment is not created for the purpose of load balancing or high availability. Blue-green deployment is a structure that we create to allow us to have zero downtime into production, right? But I always like to say that when we're trying to create deployments into production, zero downtime with code is easy because code has no state. State is always harder. I'm not saying that code is easy because we know that creating good code is particularly hard. But no matter how hard the code is, state is always harder. And in state, when I say state, we have two different kinds of state. We have ephemeral state, which is a kind of state that you store in like the HTTP session, which it has a short lifetime. So even if you lose the ephemeral state, the user was typing something, oh, maybe I lost that, I need to log in again and I need to retap the thing I was doing. He or she won't be happy, but you lost just a small amount of time or data. Of course, if you design your application like the user has to fulfill like that 200 field form before submitting, and if he or she loses that, they won't be happy. But if you lose the states on your database, I'm pretty sure it would be much worse. So we're going to discuss today about the persistent state, which is usually stored in relational databases. And why did I choose relational database? Because we, as software developers, the #1 approach for creating microservices architecture is you have a monolith and then you split it. And 90% of the monoliths that we have to deal, especially for us, that 90% of the Java developers in the world are enterprise software Java developers. So if you're talking about enterprises, we are storing our data in relational databases. So that's what I said in the beginning. I have a monolith. I want to break that into microservices, but my data is still in a monolith relational database. And what do I do with my relational database? And I want to start talking about you now. I've started a discussion about zero downtime. How do I achieve zero downtime with relational databases? So for any of you that has implementing some kind of DevOps strategy, you need to automate your database migrations. And when I say migrations, is the amount of SQL scripts that you apply between one version of your applications to the other to change the data or the schema of your database from one state to the other. Okay, so that's a database migration, and you should have automated that already. The two most popular tools in the world, in Java world at least, are Flyway and Liquibase. Both of them are like feature complete because they all have the same kind of set of features. I could say that choosing one or the other is a matter of choice these days. I prefer Flyway, just particularly because I've been using Flyer for a long time. And Flyway also works on Android because I used to develop some Android applications too. In fact, Flyway works on Android because I've patched the SQL Droid JDBC driver for Android. That's why Flyway is working. So if you happen to need to use like your migrations on an Android application using the SQLite embedded driver of Android, you have a JDBC driver which is published on Maven Central by me. And how do I achieve this zero downtime migration? So I'll say that the obvious thing is that your migrations need to be back and forward compatible, because anytime in any moment when you have a blue-green deployment, you have the current version and you have the new version running in production, and they must be compatible because you can't release a new version. Oh, the schema of this version is different from the previous one, and this one doesn't work with the previous schema, or vice versa. Okay, you can't allow to do that. So your migrations must be back and forward compatible, and to achieve that, we, as everything in life, you see a pattern here, we need to do some baby steps, which means that our migrations must have the smallest possible batch size, which means that instead of have that SQL script that you email to your DBA with like 100 lines of SQL code, it's not going to happen anymore, because most, if not all of your migration scripts will be just one line of SQL code. Okay, you have very small batch size, a very small SQL script that you're going to apply to each one of your versions. Another thing that we must be aware of is that some migration scripts, we need to copy the data from one column to the other, we have to issue an alter table, or we need to update the data because we changed the format. We won't be able to do that anymore for like a table that has like 1 billion records, because it requires locking, and it usually takes a long time to run. And when this SQL is running, usually when you have the locking, you have downtime, because the user is not able to use your application for this amount of time. So instead of just allowing you to do just like long updates with too many rows, you're going to shard your updates. And shard is a very fancy word in the technology, in the database world, which just means that you're not going to update everything in just one statement. You're going to split your statement into smaller ones until you can have a statement that is executed in a shorter amount of time that doesn't implicate into downtime to your users into production. So what does it mean? A very simple example. If we're used to this kind of code into our migrations, I'm going to alter a table, rename a column from one name to the other. Now maybe I'll need some other steps. Maybe I'll need to add like at least 4 steps to rename a column. First, I'm going to add a column to my application. Then I'm going to copy the value from one column to the other using shards. If I have 200 rows here, I'm going to update the first 100 rows because I've calculated that it's supposed to be very fast. Then the other set of rows and everything else. Then, if everything went okay, some versions later, maybe I can delete the column because I won't be needing the data anymore. So the secret here is to allow zero-downtime migrations is that you never issue a destructive statement, a destructive SQL statement into any release. So you never allow it to destroy any kind of data. You always have the previous version of data and your new version of your data into production. That's how you achieve zero-downtime. So the common scenarios that I've collected from many different teams around the world are these ones. Yeah? And you see, I didn't tackle the table problem, but if you consider a table is just a set of columns. So any of these restructuring patterns that you can see here, you can apply to tables too. And then the common scenarios are to add a column, rename a column, change the type or the format of a column, and to delete a column. So let's try the first problem. How do I add a column with zero-downtime? So see, each one of these numbers, 1, 2, 3, and 4, are one different software release, one different migration that you're going to apply to production. So version 1 is always back and forward compatible with version 2 to 3, and everything else. Okay? So you're going to first create a version, you're going to release that into production, you're just going to add a column, you're not going to use that anymore. And when you add a column, if that has a not null constraints are always the last step because you're going to have null values at least until the end of the migrations, all of the migrations. Second step, your code, you deploy new code into production, your code computes the read value or assumes a default value if that's null because it's going to be null, and writes to the new column, but it doesn't read from the column. Okay? Why? Because you deploy that code into production, and now between each one of these steps, you're going to open your database CLI, and you're going to issue a lot of select statements to check if your application is writing the data correctly into production. So then you're able to check. It's even safer this way, because each one of your deployments, you can always check your data, how your application is behaving before using that data into production. So your code is gonna compute the read value or assume a default value. It's gonna write. You're gonna check if everything is okay. If everything is okay, then you're gonna update the data using shards, because you can't just compute forever. You need to assume some value, compute for other fields, or just assume a default one. Then the latest version, your code reads and writes from the new column. When you do that, you're done with the restriction, and you can move forward. That's the simplest one. Rename a column is kind of more. It's the most complicated one. First step, you add a column. Second step, your code reads from the old column and writes to both. And of course, in this step, you're gonna issue select statement to production to check if the data is okay. Third step, you copy the data from the old column to the new column using small shards, and you need and to know which size of the shard is acceptable for you. You have to rehearse that in your test database, not in your production one. Or if you do that, at least you won't commit the updates. And fourth step, code reads from the new column and writes to both. You guess we're always maintaining back and forward compatible versions. That's why we need to keep writing to both columns. Fifth step, code reads and writes from the new column only. And sixth step, you delete the old column, but just later. How do I say later? Later, you don't delete that on a migration just after you release a new version. You just create a ticket and mark that column for deletion, so that, okay, 1 month later, after we released many versions between that, I'm pretty sure nobody's using that column value anymore. Then when your DBA is doing the cleanup of your database, then he can delete the column, because deleting column is a destructive statement, and you don't want to do that. Okay? Now the third strategy is to change the type and format of a column. And if you see a pattern here, that's exactly the same steps. So if you learn how to rename a column, then you know how to change the type and the format of a column, because they are all the same steps, which is kind of good. We're always rehearsing the exactly same steps to deploy migrations into production. The fourth strategy is to delete a column. As I said, you never delete a column into production. You don't. You just, when you, I think I don't need this field anymore. You stop using that in your application, but the column stays there. And you keep writing the value to the column. Until you know, I'm pretty sure that it has been 6 months, maybe not that much, but that nobody is using that column, then I can delete the column, and I can delete the code that is writing for the column, okay? So that's the basic steps. Everybody also asks, oh, but I'm doing this kind of restructuring in the database. What about my referential integrity constraints? You have to drop them, and then after all of your migrations are applied, then you're going to apply them back. If you think about integrity constraints, they are not required for application to run into production. They are just a safety net for you to not insert wrong data into production. And even with the safety net, sometimes you do insert wrong data into production. But it's a safety net, and I know that we're removing the safety net exactly when it's more dangerous to do that. But sometimes you need to break some walls to make improvement, and that's exactly what we're doing here with database. Oops. Yeah, that's the answer. Yeah, I just touched it here involuntarily. And that's what about zero downtime migrations. Now let's talk about, because you need zero downtime migrations with microservices, because imagine you just had a monolith, and you had downtime because of the database. Now that you have microservices, you don't have just one artifact. You have multiple. You have 5, 10, or 20. And each one of them is going to read and write from a database. Imagine if you have, if you're going to apply downtime to your system, every time each one of your microservices is updated into production. You cannot outlet. That's why you need zero downtime migrations into the database when you're dealing with microservice. You have much more downtime if you don't do that. And for the purpose of this talk, I'm going to discuss some microservice characteristics, which I'm pretty sure any microservice talk is going to deal with. But the topic that I've chose for today is just you have a lot of different characteristics. The one that I've chosen to discuss today is decentralized data management, and that's all of our strategies are about. So we have a monolithic database. I need to extract my microservice database. Unfortunately, I won't be able to discuss for you which tables do I choose to extract, because mainly that's a modeling problem. And I won't be able to tackle that because if that's a modeling problem, it really depends on your model. So there is not an easy question for that. I strongly suggest you to study and apply domain-driven design to both your code and your database. It will make this process easier, but I won't be able to help you today on this topic. I'm gonna just help you. You decided that this set of tables and columns, these are my candidates for splitting. So I want to change this from this database to another database. Okay, you already decided. Then we're going to migrate. Then that's the strategies that I'll be talking about. So the first concept about microservice architecture is that you need one database per microservice, but I still have an old monolithic database. And don't be scared. I'm pretty sure that for a great amount of time, you will have your microservice and your old monolith is still reading and writing from the same old monolithic database. That's a pattern, because that's too risky for you to just take everything out and deploy in a separate artifact, because most of the times people do that wrong. And after you split the data, it's very hard to get this integrated and back together. So the safest approach is, for a certain amount of time, until you're pretty sure that you did it right, both of them are going to read and write for the same monolithic relational database. But if splitting is not easy, how do I integrate later? Because you see, your data is not isolated from the other parts of your system when you process information. So if you decide, oh, customer table and its relationship with like address and phone numbers and transaction history and everything else, maybe customer is an ideal candidate for a microservice. Maybe I can split that, but the rest of your system still needs the data from the customer. And the number one mistake that every people do, we've implemented DAOs, we have a data access layer, so every time that everybody needs a customer, I have a customer microservice here. I'm just going to create a REST endpoint. And my DAO is not going to access the database anymore. It's just going to create an HTTP request to my REST endpoint and get the data back. And when they deploy that in production, they just fail, because you realize that this approach doesn't scale. It's extremely slow. As you see, an HTTP request is not like, because the database is extremely fast. It's like milliseconds. And like 1 millisecond, 2 milliseconds, that's this kind of scale. When you add an HTTP request, you're gonna start talking about like 100 milliseconds, 200, 400. That's the kind of overhead that you add when you add a REST endpoint. So REST endpoints, usually they are only feasible when you have very low data access rates to your data, which is probably not the case for your customer database. You need another way to integrate this data later. And before we dig into the ways that we can do that, I need to start a discussion about consistency models. And I'm going to present to you an oversimplified explanation of what are consistency models in distributed systems, because we have a lot of different them. But the two most important for us in this discussion today are strong consistency and eventual consistency, okay? And for us, again, that's an oversimplification. Strong consistency means that if we have two different nodes, which in our case is going to be monolith and microservice or multiple microservice, if you have two different nodes with a strong consistency, it means that if I write in one node, all of the nodes in the systems, they must agree on the new value before anybody can read this new value, okay? So if I say write 5 here, everybody has to agree, okay, 5, 5, 5, 5, 5, before the 5 value becomes available to clients. That means strong consistency, and that's usually what you achieve when you have like transactions between your nodes. If you have distributed transactions or if you have local transactions, that's the consistency model that we're used when dealing with databases most of the time, because even with databases and transactions, we don't have strong consistency all the times. We only have strong consistency if our transactions are serializable. But most of us, for performance reasons, we configure our database for repeatable reads. So it's not strong consistent anymore. So think about it. Even when we're talking about local database transactions, it's not 100% strong consistent. So we need to clear our minds a bit, and we have to embrace what we call eventual consistency, because most of the systems that we deal in every day, they are already eventual consistent. We're just not used to think about that. And again, an oversimplification, eventual consistency, in our case, means that if I have multiple nodes in my system, there is a strong, special case of eventual consistency, which is the one we're going to apply here, which is a strong eventual consistency, which means that if I have multiple nodes in my system and only one node can update information, only one node is the canonical source of information, which will be in your microservice architecture. You can update the nodes, and this node, the canonical node, and the other nodes in your system can have correct values, but maybe outdated ones, okay? Because I can write here, and the information can take some time to be propagated to the other nodes, so you're gonna have outdated information, but that's correct information. That's correct information for like from 5 seconds ago or half an hour ago. It really depends on your use case. And you don't have to be scared about that, because even if you design a system, you're gonna query your current bank account money. You type your bank account information on your web interface, you went to the database, you read the data. At the time you read the data from the database, it's outdated already. Because the thing that you're seeing on your display is the information that you had like a second ago. Somebody could have updated it already. So all the information that we see on our systems is already eventual consistent. So we just need to deal with how much eventual consistency can we handle in our system. If that's 1 second, is that 5 minutes, is that 24 hours? Most business strategy decisions are taken with data from yesterday. So they take decisions based on like information that is eventually consistent from 24 hours ago. So maybe you need to decide how much time can I accept when I have to receive outdated information. Okay. Another thing we need to discuss is that if we're going to have eventual consistency, we are going to need the secure RS in our system. And I decided to explain this because I've seen a lot of explanations around CRUD and secure RS. Many of them are wrong, and when I ask people about secure RS, they usually have different concepts about it. So I propose to explain in a very simple terms what is CRUD and what is secure RS, because CRUD I think everybody knows what is, but secure RS very few people understand what is really secure RS. And I'll show you here CRUD. CRUD is create, read, update, and delete, which is usually means that you have if you look from the code perspective, CRUD means that you have the same model, you're going to use the same exactly set of classes, for example, customer, for writing to your database and reading for your database. That's CRUD. So you have just one table customer, you have a customer class in Java, you're going to use the customer class to write and delete. That's CRUD for data. Okay? That's simple. That's what we do on a daily basis. That's the simplest possible kind of architecture. And usually, that's the best approach for dealing for most use cases of data management. So don't start thinking about secure RS just because you want, because most of the time, CRUD is the best answer. Secure RS comes to mind when you have some different kinds of requirements. And secure RS, it means command query responsibility segregation, which is just a fancy name, meaning that now you don't have a single model for all the operations. Now you have separate models for reading and for writing, okay? Which means that you can still have the customer class for writing, but when you're reading information, it's not the customer class anymore. It's like a customer report class that you're using to show the information. Why? Because maybe the customer has too many fields or too few fields, and when you query the information from the customer, you want more information aggregated from different tables. And usually you you have to deal with multiple joins and everything else. So you don't want that whole graph stored into memory just for you to show the customer reports to your user. Then maybe you need a different model. That's when we have CQRS, you have a read model and a write model, which means you're going to read using a class and you're going to write using a different class, and you're going to read from a table and you're going to write from a different table. Sounds weird? We've been using that for a long time. People just don't recognize that this is CQRS. So it's just the name that is not common, because the strategy is very used. When we create a report, when we have to model that in Java, sometimes when we have a very complex report, we create a class called like custom report DTO, isn't that? Data transfer object. And when I'm saying DTO, it's just because this DTO, it's anemic. It doesn't have behavior. It's just a placeholder for count information. It's not a DTO from what we used to call from EJB 1.1, 1.1, or something else. So it's just a holder for information, so it's a dump class. And when you realize that you can use different models for reading and writing, you realize that you're not constrained to having just one database to read and one database to write. Maybe the information that you're storing, you can have just one write data store. Customer is a bad example, because customer you should be using crud. But if you have, for example, transactions, money transactions, or like phone billing systems, or something else. If you decide that you want to store, if you decide you want to use event sourcing, for example, and you want to store all of the transactions in the right database, but so the transactions are the canonical source of information, because if you know that every bank account starts with 0, and if you get the history of transactions, if you apply all of them, you always get the current amount of money that you have in your account. Okay? So transactions are the canonical source of information. But the read information, you don't want to replay all of the transactions all the time to know how much money you have in your account. So maybe you want to create another table which stores the cached value of how much money you have on your bank account. And this information can be updated synchronously or asynchronously. So every time somebody applies the transaction, you update the cache. But this another table is just a cached value. It's not the canonical source of information, because the truth is on the set of transactions. This other table, where you have the total amount already computed, is just used for performance reasons. Okay? So number one case for CQRS in most enterprise systems is performance. We have some things that are computed that takes a long time to be computed, and I just want to store a cached version already calculated for me to read it. That's the classical use of CQRS, right? People use a lot of that for reporting. And when we're talking about CQRS and event sourcing, that's exactly the example that I gave you today. CQRS can be, you don't need CQRS for event sourcing or vice versa. But if you do, they usually are a good match. Transactions are a good example of event sourcing, and CQRS is a good example of caching of that transaction information, okay? Which is just the example that I gave to you. So we decided that we need CQRS because we've been talking about microservices. When will you decide that you have a customer microservice here, but the rest of your system needs the customer information, and accessing the information through REST is not an option, then the rest of the system is going to need a copy of the customer information. This is going to be CQRS, because the right repository is the customer microservice, and the rest of the system is going to have a customer information stored probably in a table in the database or in an in-memory cache. It really depends on your use case, but it's going to have a copy of your information, right? So this is CQRS, and how do we create this CQRS strategy using microservices? I've been able to collect 9 different strategies in the past 1.5 years, so that's what I'm going to show you today. And that's the main subject of my book anyway. So the possible strategies for creating this CQRS approach in your microservice architecture are shared tables, database view, materialized view, trigger, transactional code, ETL, data virtualization, event sourcing, and change data capture. And which one is the best? None, because it really depends on your use case. Okay, I don't have a best alternative, but I have some favorite bad alternatives. Okay, I know which ones are very bad, but I have like good alternatives for the other use case. You know?
What about queuing? It's part of one of these.
Queuing? Yeah, usually I describe that on event sourcing. Okay, when you have distributed messages. Okay. In fact, we use queuing in a lot of different, but I imagine that's queuing of business messages. Is that? Or any kind of message? Because we use distributed message in many of them. Data replication? Okay. Yeah. Maybe that's CDC. I'm going to show a demo about that. Okay. And we can have shared tables. Shared tables is the quick and dirty approach. I just create a separate code database, and both of them are reading and write from the same tables, which is especially bad thing. But if you do that because you know that you're doing a dirty thing, and as soon as you can, you're gonna change that. Okay, which means that usually when you have shared tables, it's the strongest type of, it's the fastest data integration because you have to change nothing. But when you have to change nothing, that's the reason for you to not change anymore. Because if you have two different code bases accessing the same tables, that's the perfect excuse for you. I can't change this table here or this code here because it's used on the other code. And you can't change here because it's being used somewhere else. And it's just the case when you have two artifacts. When you have 3, 4 accessing the same tables, it quickly becomes unmanageable. So it's one of the greatest technical debts that you can have using shared tables. So if you do that, just remind yourself to remove this approach very quickly because it tends to be a burden when it gets older. You have a strong consistency because when you're accessing the same tables, you have transaction, database transaction on that. And usually this approach leads you to low cohesion and high coupling between your artifacts. That's why you don't want to use this approach. You can also create database views for your CQRS approach in your microservices, Monolith, or different microservices. You can, database view is by far the easiest one to implement because it has the largest support from all of the DBMS vendors. I've tried even embedded database like SQLite or in-memory database like H2. They have views, so it's not really an excuse for not using views. You can have possible performance issues depending on your database and how you create your view. Because you're always on the same database, you have strong consistency. The downside is that one database must be reachable by the other, which means that if you have split your database, one database here, another database, you need to link them. And at least on Oracle, some DBAs are going to be crazy about me when I say this, you can create a DB link. I know some people hate, some people love. I've used it in some use cases I've seen people using. Yeah, I know. Yeah, I've heard that a lot. But sometimes it works. Okay, I've did it sometimes, and sometimes it works. And also, it can be updatable depending on your DBMS support. And I know that at least on Oracle, it's true. You can have that updatable views on Oracle, which also means that you're not going to have just a canonical source of information anymore if you allow both ends to modify that. Okay, just have in mind. You can also have database materialized view, which has better performance than views. When you have the materialized views, you can have strong or eventual consistency, which means that if you update a materialized view on every transaction, it's a strong consistent. If not, if you update that on a time trigger or on demand, then it's eventual consistent because it's outdated. Again, one database must be reachable by the other. And it's updatable depending on DBMS support. And you're already using materialized view for big reports when you have data aggregation, multiple group buys, and everything else. You're already doing this kind of CQRS for performance reasons for reports. Then you can use the same approach from reports to microservices too. You can also use database triggers. And then again, we are on the dirty side of the approaches because very common, unfortunately, and it depends on DBMS support. You always have a strong consistency because you're running on the same transaction. Basically, one database must be breachable by the other, but database trigger, if you decide to do that, it's only feasible if you have just one microservice and one monolith to integrate, because triggers, they are very hard to maintain, and they are almost impossible to maintain if you decide to create a third microservice. Now you need to integrate 3 different endpoints, and you decide with exponential combination, because one update here must be propagated to these 3 and 4 and back and forth, so it quickly becomes unmanageable. If you decide to do that, have in mind that it's just for a quick hack, just as shared tables. Shared tables, I think, are even worse, but triggers are bad too. You can use transactional code, which again is the same thing as triggers. Yeah, it's impossible to manage when it grows. And I say transactional code, it can be any code, it can be stored procedures, or it can be distributed transactions. Both are hard to maintain, to achieve. In distributed transactions, especially hard to do it right. So, but if you do that, you have a strong consistency. You can have possible cohesion and coupling issues, because if you change one thing here, you have cascading changes. That's why you don't want to do that. You can have possible performance issues, and again, since it's code, you can do whatever you want. It's updatable depending on how you implement it. Another approach are ETL tools, which most of us know ETL tools as business intelligence tools. So we have a lot of different options for these tools. If you ever used a Pentaho or ClickView or any other BI tool, that's the kind of tool that we're talking about. ETL tools usually requires an external trigger, which means it's usually time trigger, or you push a button to run the update of the information. You're not constrained to just one relational database. You can aggregate data from multiple sources. So depending on your microservice architecture, you can have a relational database here, you can have flat file somewhere else, you can use in-memory database elsewhere, and ETL tools can aggregate all of that for you out of the box. You just need the right tool and the right plugins. It's always eventual consistent, because once you read that, you can read all of the sources inside the same transaction, but when you did that, it's already outdated. So it's always eventual consistent, and that's a read-only integration, because ETL tools are designed to be one way. There's no way for you to propagate the change information back. Data virtualization. Now I think I'm dealing with the recommended approaches. One of that is data virtualization. And the good points about data virtualization is you have your physical database, you create another layer on top of that where you can create your VDBs, which is your virtual database. Initially, your virtual database can be an exactly copy of your physical database, but then you can start changing your VDB and not change the physical databases. So the good point about VDBs is that it has real-time access. You touch the VDB, you're touching the physical database. So there is a strong consistency. You can also aggregate from multiple data sources, because you can create a VDB from multiple relational databases and even from multiple different sources. Then it depends. If you're using flat files, of course, you're not going to have transactions on the flat files, but you can have transactions between the relational database at least. And it's also updatable depending on the data virtualization platform that you use. I have a graphic here, which is small, but yeah, I don't expect you to see that. I just want to show that on the bottom, you can have multiple different data sources. Then you can have a data virtualization platform where you can create multiple VDBs for you. As I said, it's very hard to decide which tables to split to a microservice. The easiest and safest approach usually is using virtualization, data virtualization, because then you can choose, oh, we're not going to touch the real data, the real relational tables. Let's try to get this customer table and this dependencies to, let's try to create a VDB and code for that integration. Oh, things went wrong. I think we chose the wrong tables. Then you just have to delete the VDB. Everything is in the way it was. Okay? But if you decide it's right, oh, we split that correctly, then the VDB approach is working well. Maybe now we are safe, we are confident that we can split the physical database, then you do that later. So I always like to propose data virtualization as a safety net, because you can play with the things. If anything goes wrong, your data is still there working. That's why I like the data virtualization approach. It can work in most use cases because you might have different applications for your virtual database. But it's especially useful when you're trying to migrate your monolithic application into a microservice architecture. Event sourcing means that the state of data in your system is going to be a stream of events. And usually it requires that you change your code. And if you have especially legacy database code that you, application code that you don't want to touch, maybe that's not the best approach. So when I'm talking here about event sourcing, it means you have to change your code. So if your code is already modeled as event sourcing, just as I said, transactions and a cashier, it's kind of easy for you to get these messages instead of just propagating these messages internally in your system. You get these messages from the event sourcing, you delegate that to a message bus, and your microservices starts consuming these messages. Okay? So if your system is already modeled like that, maybe that's an easy transition. If it's not, then you probably won't want to do that. It's very hard to refactor a system to use event sourcing later. But if you have it, it eases auditing because, again, you can always replay all of the transactions to check if the state is correct. You have to usually combine that with a message bus. And if you do that, it's highly scalable. And the latest approach is change data capture, which is kind of event sourcing too. And it's my favorite approach for code base that you don't want to touch, because CDC is a strategy that you take a tool, it plugs into your database. You can ask, I want to be notified of changes in these tables, in these columns, and everything else. So what it does, you don't need to change your application code, but for each insert, update, and delete statement that you make on these tables or these columns, the CDC2 creates an event. This event usually is propagated through the message bus. Then any of your clients of the message bus can take this message and update its internal model with the updated information. Which means that if I have a customer database and I update there, then the CDC2 propagates, oh, customer has updated its name from X to Y. Then all of the clients of the message bus can receive, oh, different name. I'm going to update my internal cache. Right? And you can have like the customer event can have multiple fields. But when I'm dealing with just want to show the customer name in the screen, I can take the message, I can ignore everything else, and I just store the customer name because that's the only data that I need in my internal SecureOS data store. Right? So CDC, it's a very neat approach for integrating microservice architectures with SecureOS. And I especially want to show you a demo of Debezium, which is an open source project sponsored by Red Hat. You can just check the website and download to start using that. If you ever used Oracle Golden Gate, Debezium I think uses the same, but it's free. So maybe that's a good reason for you to try, because Golden Gate is expensive, right? Very expensive. And I'll show you Debezium. So Debezium currently works for MySQL. I think Postgres was working too. MongoDB, and we have a work in progress for Oracle, and the next is SQL Server, right? And once the Oracle support is finished, it's gonna be 1.0 because the business is like 0 point something yet. Trinity? Trinity? I don't know. I only played with Golden Gate and Debezium. Okay, and most of the people that have also free. Okay, interesting. I didn't check that. I'll try to Google later. But I'll say Debezium, well, because that's a Red Hat project and I work for Red Hat, okay. Because it's cool, because I know some of the engineers, and they're very helpful too. Like 90% of the people that I've talked around the world about these problems, they use Oracle. Okay, yeah, and yeah, they always talk about Golden Gate, but Debezium is a work in progress, right? It's going to reach 1.0 when the Oracle support is stable. Okay. And I want to show how it works. So, okay, I have here. Okay. Can you see it? Yeah. Oh, well, there's nothing to see in this message, okay? I just want to show that I have a zookeeper running. Zookeeper is a Kafka dependency. If any of you has ever heard about Kafka, Kafka is a very high performance distributed message bus, but not the traditional message bus that you are aware of, because Kafka, it's high performant, it's distributed, of course, and it's persistent. So Kafka stores all the messages until you say, you tell Kafka to not store them anymore. At least it has a long cache, long persistent storage. So you have Zookeeper to maintain the global state between all of your clients, Kafka clients. I have here a Kafka bus running. I also have here a MySQL server running. So that's the basic things that I want to show, but the cool things are here. I have a MySQL CLI. I have here Debezium running. Debezium uses the Kafka Connect client to connect to your database. So basically, Debezium here is connected to the MySQL database, and I told Debezium to listen for the customer database. So anything that happens in the customer database is going to propagate an event to Kafka. And if you ask why it's named Debezium, because, well, it comes from DB, a database, and they added the zium because they wanted it to sound like a chemical component. So Debezium. So maybe it could be it could be on the periodic table. And so here is a Debezium Connect. And here I have a Kafka client, which is just showing the messages that are happening in the Kafka bus, okay? So I'm gonna try here. So luckily for this demo, I have a ready to go script. So I'll try here. If you show databases, is it good enough? Use inventory. So if I get here, customers, database, I can see 4 records here. I have for ID 1004, it's N. Let's try to update N's name to Emahi. And update it. If I select here, it has been updated. Let's see what happened on the Kafka bus. Oops, now I have a message. That's a JSON. Message propagated. It has very cool information, which I'm going to print to you. So if you get here, Debezium gets because you can issue an outer table statement, and Debezium propagates that too if you configure it to do so. So you always have the previous schema, the new schema, which in this case is the same. But the interesting information here from Debezium is that you have the payload of the message. That before, the ID 1004, the first name was N, and now the after one is Emahi. So you have all of this information broadcasted through Debezium. And Debezium also has some internal information from MySQL, and it propagates the operation. I've just created an update statement. So you can catch the operation. Oh, it's going to update. I need to update my internal database too. And I get which field changed. Well, it shows you which one all the fields were changed. And you can use code to change your internal representation. So what else I can do? I can delete two. Okay, I only have 2 minutes, so I'm not going to skip delete, but I'm going to show the interesting part. The other question that people say, okay, Debezium is connected, but what if Debezium goes down and it stops propagating message from Kafka? That's what I'm going to do now. I'm going to shut down Debezium, the machine running Debezium that's just stopped. And people now are issuing some things into, I'm inserting fields into MySQL, right? I have 2 new items here, Sarah and Kenneth, and Debezium is stopped. It didn't read from MySQL and didn't propagate that. But what happens if I just start Debezium again? You see, I'm here. Nope. Debezium knows where it stopped. So when it was up again, it knows, oh, I've stopped where? I stopped here. And now it propagated these new messages, which I should have. It's big font. Which here. I can just show you that this last message is the insert for Kenneth Anderson. You see before, we didn't have any data. And now the after, I've just inserted Kenneth Anderson. and the operation is create one. Okay, so that's the cool things about Debezium. It works the same no matter which database you chose: MongoDB, MySQL, Postgres, and now very soon Oracle and SQL Server. So that's what I wanted to show you for today. And I'm already out of time, so if you have any questions, I'll be available to answer that for you. But I don't want to take time from the next presenter. So please join developers.red.com. You can get the ebook for free. The feedback will be more than welcome. I'm always available in my Twitter handle, @Yanaga. In fact, that's the easiest way to keep in touch, because I have lots of email to read, and usually I take a long time to reply. And thank you very much.